Okay. In this problem, we have an integral, a definite integral that has a couple of things going on. We've got an absolute value of a quadratic, and we also have a negative on the inside. So what I'm going to do first is I'm going to rewrite the problem with the negative on the outside. And then I'm going to think about what this graph looks like, the absolute value of x squared plus 5x. So you can use your graphing calculator. I'm going to tell you how I'm going to get an idea of what this looks like without using a calculator, but feel free to use your graphing calculator. This quadratic is going to have x-intercepts at x equals 0 and x equals -5. And normally a quadratic will come around and look like a parabola, but because it's an absolute value, whatever's below the x-axis is going to bounce back up. So that's the part of the parabola that would have gone underneath the x-axis. So it looks kind of like a W, okay? So when we're taking the integral from -6 to +1, remember we're finding the area underneath that curve. So I'm going to find, let me use a highlighter. I'm going to find this area right here. And then I'm going to need to find, let's make this green. Then I'm going to need to find this area right here. And that blue is fine. And then we're going to find this area right here. So that's going to be 3 different integrals. So I've got the opposite of, and I'm going to use brackets here because that negative on the outside, I'm just going to worry about that at the very end. So I'm going to have the integral from -6 to 5 of x squared plus 5x. So that is most definitely x squared plus 5x because I didn't have to flip it. This part right here was part of the parabola. Plus the integral, from -6 to -5. And then plus the integral from -5 to 0. And that's the green part. Okay. So I'm going to use that. And I'm going to use this. This is the green part right here. And that was because I had to flip it up, I had to take the opposite. That's what flips it up, the opposite. So I'm going to have, instead of x squared plus 5x, instead of x squared plus 5x, I've got the opposite of all of that. So I've got -x squared minus 5x. So -x squared minus 5x dx. And then we've got the last piece from 0 to 1. And that is the original x squared plus 5x. And now we're going to find the area under each curve through integration. So I've got my negative on the outside. And then I'm going to have x cubed over 3 plus 5x squared over x from -6 to -5. Plus, I'm going to continue to use my highlighter here. Plus, let's see what we have here. -x cubed over 3, I'm going to use parentheses, minus 5x squared over 2 from -5 to 0. And then I've got plus x cubed over 3 plus 5x squared over 2, evaluated from 0 to 1. And then I'll end it all with that last bracket. So remember that when you do definite integration, you're going to put the -5 in, get a value, and then subtract the result from putting -6 in. So I'm going to need a lot of parentheses here. So let me just use this. I'm going to do this in yellow. Okay. And then I'm going to have a green part. I'm going to have this blue part here. And I'm going to remember, I'm going to add all of these parts together. So I've got plus, plus, and then I'm going to take at the very end the opposite of all of it. So when we put the -5 in, I've got -125 over 3 plus 125 over -5. Oh, I caught a mistake. That was supposed to be a 2. And I might have even said 2. Yeah, I might have even said 2 and wrote it, but I'm not redoing this again. Okay, so that's putting the -5 in. Now I've got to put the -6 in. So look at what I'm going to do. I'm going to resize this because I need a little bit more room. Okay, so now I've got to subtract out putting the -6 in. So when I put the -6 in, I get -216 over 3 plus 36 times 5. 36 times 5 is 36 times 5, 180 over 2. And now we're done with that yellow piece. Now we're going to do the green piece. When you put a 0 in, you're going to get 0 over 3. Yeah, I'm just going to show my work here. 0 over 3 minus 0 over 2 minus, and then we're going to put the -5 in. So -125, and then I've got the opposite of that, so that's going to be positive 125 over 3 minus 25 times 5 is 125 again over 2. And now we've got the last piece, which is this blue piece. When I put a 1 in, I get 1/3 plus 5/2 minus 0/3 plus 0/2. And now it's just fractions. Now it's just working with the fractions and seeing what we get. So I'm going to have that opposite on the outside. And I've got -125 over 3 plus 125 over 2. I'm going to distribute this negative. And I'm going to get positive 216 over 3 minus 180 over 2 plus this part right here is 0. So now I'm going to distribute this negative, and I get minus 125 over 3 plus 125 over 2 plus, and now we're at the blue part, 1/3 plus 5/2. -125 over 3 minus 125 over 3 is -250. -250 over 3 plus 216 over 3 plus 1 over 3. So 250 minus 217. That's going to be a 33. So I believe, unless I've made a mistake, I've got -33 over 3. Oh, that's a nice number. And then we're going to have 125 over 2 plus 125 over 2, that's 250 over 2, minus 180 over 2 plus 5 over 2. So 250 minus 180, that's going to be 70 and then 75 over 2. 75 over 2. So I've got the opposite of negative 11 plus 2 goes into 75, 37.5 times 37.5 minus 11 is 26.5. And then I've got the opposite of that. So the opposite of 26.5 is going to be negative 26.5. And I have to say that this is my 7th time making this video. And I appreciate you not fretting about the fact that at the very beginning there I had an X right there, and you were probably going, what in the world? But sometimes we do that. And if you just take it slow as you're doing the problem, when you make a silly mistake like that, you know better. You might even be saying 2 in your head. You've got an X right there. If you take your time and go slow, you'll say, wait a second, that was a mistake. And you will catch those mistakes as you go through. If you go a bit too fast, then that's where you don't catch your mistakes and they follow you through the entire problem.